Hello everyone, today this video is going to be about aiming. Once you start getting into the world of firing off projectiles, whether they're ballistic projectiles that come from things like guns or energy projectiles or even magic projectiles, you'll find that without certain assistance, aiming can be quite challenging. So I've got a little scene set up here to kind of show you what I'm talking about. So we've got a science fiction environment, and I'm playing as this character. At the other end of the room, there is a dummy enemy. And I should be able to shoot at anything that I see here. But let me try to shoot at this box and see what happens. Now that was a lucky shot. Let's look at this one. I missed. Let's try again. I got a little luckier that time. How about this one over here? That one I nailed. Now let me see if I can shoot the robot from this distance. That was a miss. Rotate myself a little bit. Nothing's happening, right? But let me show you what should happen if he gets hit with my projectile. See, I'm still having difficulty aiming. That's supposed to happen. Okay, so we are going to make this a lot easier on ourselves. And we're going to start by creating the crosshair. And the crosshair is just going to be something in the middle of our screen. In our root content directory, I'll right-click, make a new folder, call it crosshair. So, and open that up. This is going to be done using a widget blueprint. To make one, you right-click and you hover where it says User Interface, and you choose this, Widget Blueprint. Widgets are things that can be displayed on the screen, things like health bars and other like points and whatever, callouts. But this one is just going to be a simple crosshair. So we'll choose user widget, and I'm going to call it UI underscore crosshair. UI is a typical prefix for widgets because it means user interface. So we'll open that up. And when you're making a widget, the first thing that you need is something called a canvas panel. You'll find that under this little drop down where it says panel, and it should be the first thing in there, canvas panel. So I'm going to drag that into the graph, and this represents our viewport. So you can use anything you want as a crosshair. If you went on Google search and just searched for crosshair and then looked at the images, you'd see many, many crosshairs, and the only thing that's important is that they have a transparent background. Any image at all could be used. It could be a smiley face. It doesn't even matter as long as it has a transparent background. I'm not going to use an image today. I'm going to use just a plus sign, and I'll therefore take a text box and drop it roughly into the middle of the canvas panel. Now, by default, it'll say text block, but I don't want it to say text block, so I'll highlight that here where it says content, if you have to twirl that down, text. Highlight this, and I'm going to replace it with a plus sign. While I'm there, I'm going to center justify it and also make it larger, maybe something like, 50. And try to resize this box a little bit around it more symmetrically, so it's more square-like. Okay. The box, by the way, is not going to show up. Only the pluses. Now, because that's white in color, I like to also do an outline around it. So if all this stuff is folded up, just make sure you disclose the font and then the outline settings. For my outline size, I'll make it 3 pixels. And I'm going to leave the outline color set to black. That way there's going to be a black outline around this, which will help it remain visible if it happens to be displayed over something with a very light background. Now, even though this might look like it's in the center of my canvas panel, it probably isn't. So what I want to do is I want to use an anchor. So I'll go up here to where it says anchors, open that up, and you can see this is going to just like basically determine the position where something is going to be on your screen. I want this crosshair to be dead center, so I'm going to choose this particular anchor. And I can see where that is. So I'm going to zoom in, and I want to get my plus sign aligned with this little anchor symbol, looks like a flower, as closely as I can. And I find that using these position X and position Y controls here really help me get that lined up. So I want like the center of the plus sign. I'm really doing this by sight, but that is very well close enough, okay? And yeah, it doesn't really matter so much if these aren't whole numbers. I mean, that's probably negative 53. Let's try that, negative 53. And this is probably negative 40. Okay, so that's probably perfect right there, okay? And I will simply compile and save, and there's nothing else that we have to do in this blueprint for the time being, okay? The next thing I'd like to do is to add it to the viewport, and I'm going to do that inside our characters blueprint. So all the characters in this level I've kept in the third person character folder, and I will go into blueprints, and here we'll find the blueprint for our hero, the one that we're playing as. I called it BP_cyberpunk girl. And I'm going to give you a little bit of a tour of some scripting that I've already done. First of all, there is a custom event that I made here called Cast Power. And essentially what's happening here is that when it casts the power, some of this stuff is for sound, and I'll get to that in just a second, but it's going to play an animation montage of her shooting that power out of her hand. And once that happens, coordinated with a certain time, it's going to spawn our projectile. And you'll recall we've spawned projectiles before, and remember we had to do some special workarounds to make sure that we could aim up and down. So I've got a scene component, and the scene component is in my components list. If I go to the viewport, let me show you something. There is a scene component right here, and if I show you from the front view, this is not exactly aligned with the character, okay? I chose this location for the scene component based on the animation that this character is going to play when her hand is at full extension. So in order to determine that, I selected the mesh, and I temporarily took it out of its animation blueprint and instead chose Use Animation Asset. When you do that, you're going to have to choose the animation sequence that you're using, but when you do that, usually by default it'll be playing and looping. So all you have to do is simply turn those off, and then you can use this initial position to try to find exactly where that is. You can also do it by scrubbing through the animation sequence itself. But I found that about 0.8 seconds into that sequence is where is the time at which I want to spawn the projectile. So, and I also wanted to make sure that it spawned here roughly in front of the hand. So I created a scene component, and that of course is just done by clicking the add button, type scene. And the one you want is just this utility scene component. A scene component is just simply something that has a transform. And it has to be a child of the mesh in this case. Okay, so I selected the mesh first and then added the scene component. And then I just positioned it where I wanted it. Okay, that's gonna provide our spawn transform for the projectile when it spawns. I could also have done that with a socket on the skeleton if I wanted to, but I just chose to use a scene component. One other word about scene components is that if you're colorblind like I am, usually they've got this rotated 90 degrees to the left, so I don't know why that is, but I find that almost always I don't notice because I can't tell the difference between these colors, and then my projectile shoots sideways. So be sure to rotate that. If you're using a scene component, rotate it 90 degrees so that the x-axis here in the legend corresponds to that color, okay? So that's how you'll be able to tell. So going back to the event graph, oh, you know what? I want to put the mesh back into its blueprint. Don't want to forget to do that, and it'll remember whatever I had last selected. Go back to the event graph, and it's spawning the projectile at the location, the world location of the scene component. So I drag the scene component into the graph, just like that. I don't need this one. I already have it. And then I chose get world location, and that went into the spawn transform location. I mostly did the same thing for the rotation. I pulled off the scene component, I beg your pardon, and I typed get world rotation. However, I could only use the X and Z values for that, because if I use the Y value, I would not be able to aim up or down. So to aim up or down, we split the struct, and you know what, I can even show you, just so you'll remember this. Disconnect everything here. Okay, this usually starts as just a rotation struct. But if I split it, okay, and I'm getting the world rotation of the scene component, I'm going to plug X into X and Z into Z. And then I search for get control rotation. So get control rotation, which is the rotation of our mouse in this case, okay? And once I have that, I can use the Y value of that for the pitch. And also, this is going to require as its target the player controller and also the player state, okay? And when you're trying to find the player state, you can pull off and just type state. That's the easiest way you get right to it, get player state, okay? So, all right. One other thing I can tell you is that if you're going to be getting the player controller, just make sure that the self, if you look under possession, that it is auto-possessed player is set to player 0 instead of disabled. Okay, and it defaults to disabled. So I set this to player 0 just so that I would know that this controller, the player controller, corresponds to this, this character. All right, compile and save. And some things are going on here as well. I'm playing some sounds. You could probably tell that there's an effort sound when she winds up and then casts the spell. It was important for me to learn about when I want that to happen, because normally when I do this play and a montage, well, you can see that even before that, as soon as I disable movement and stop movement immediately, I want to play this particular sound especially. This is a sound that I got from a pack that I bought from the marketplace called Human Vocalizations. And I just searched for a female effort sound. And this is going to happen as she's winding up to cast that spell. And I also included some other sounds that, frankly, I didn't even design. I just found them in the engine content. You can go one level back from your main content directory, and you'll find that there's other stuff hidden in there, like certain sounds. And I just used these as placeholders, frankly, and they worked okay. So then it plays the montage, and I had to find the montage that I made for that particular animation sequence, and that's the one we were looking at a moment ago in the game, but also in the viewport of this blueprint. Normally, we would follow that with a delay and use the return value of the montage to populate its duration, but in this case I did not. There was a deliberate reason. I wanted to delay this by 0.8 seconds because what I wanted to happen basically 0.8 seconds into the montage, rather than after it's completed, was to play another effort sound, as well as the sound effects for that I'm using to, these are also placeholders, by the way, for just like the sound of the projectile and then spawning it. I wanted all of that to happen 0.8 seconds into the montage. But I also wanted to make sure that when the montage was completed, I have this sequence here and another delay. And I took the return value of the play montage and plugged it into the duration of this delay before I set the movement mode back to walking. And again, that's off of the character movement component, which you can get anytime and just drag into the graph like that. Okay, so this is that entire custom event in summary. So now I just have it taking place off of the left mouse button, right? So I've just chosen a temporary input, the prototyping input, left mouse button. And when I press that, I'm calling this custom event, which is this. Okay, so it fires off all of the above, so to speak. Okay, and you can see it one more time as it looks in the game. Yeah, I'm a pretty bad shot. It's easier if you have something visual to assist you with this, and I'm going to show you exactly how to do that right now. So let's go back to our content directory, and I'm going to start by making a crosshair. So that is just like a little thing in the middle of the screen, something visual that shows us where we're aiming. And you can use anything as a crosshair. You can use an image, for example. There are plenty of crosshair images on Google Images. You can use really anything. It doesn't even have to be a crosshair. It could be a ladybug or a smiley face or anything you want, as long as it's an image that has a transparent background. Today, I'm not going to do that. I'm just going to use a plus sign, and that will make a crosshair just fine. So let's make a folder. I'm in my main content directory. I'll make a folder. And I'm going to just call it Crosshair, like so. Oh, did I make that folder already? Let me see. Did I already do this? Let me see, Crosshair. Did we make it already? Boy, yeah. What a lousy memory I have. Anyway, so we already saw that part. So what we need to do now, I beg your pardon, is to get it visible. So I'll do that right off of begin play, and if I go to the top of the graph, you'll see that a character has a begin play node already, and it's doing some stuff, and then we can come right after this add mapping context. We will pull off and type create widget. Can't believe I just explained something that I already explained. That's kind of embarrassing. And I remember now, though, we called it UI_crosshair. You don't have to do anything with this owning player necessarily, but you could if you wanted to. It wants the player controller, so I guess I could get player controller. I've never found that it's necessary, and let's see if this is needing anything. No. Okay, so it doesn't need like player state or anything like that. But I'm pretty sure that you don't need to do this. Okay, so you could if you wanted to. I don't think it's necessary. Take the return value and then type add to viewport, like so. And make sure that the return value from this create widget is connected to the target. Okay, compile and save. Now we'll be able to see it when we go into the game, but it's still not going to help us aim. See, I just aimed it not at the robot, but if I aim it at the robot, I'll probably miss, okay? Because right now that's just sitting there in the center of our screen, and to be honest with you, our projectile is just not rotated towards the center of our screen. Going back to this blueprint, speaking of the crosshair, going to the viewport, I want you to know that to see the crosshair well, you're probably going to have to change the camera location. And if we look at this from the front, you'll see that the camera is not directly behind the character as it usually starts off. Instead, I brought it closer up a little bit and then off to the side a little bit, off to her right side a little bit. First of all, the way that I did that is not by actually changing the transform of the camera, but manipulating the camera boom that it's attached to. So with this camera boom, let me just clear my search here. You can see that I shortened the target arm length. I think the default is 400, so I set it to 225 just to bring it closer. And I translated it to the right a little bit by, it looks like 110 degrees. And I translated it up a little bit just by hand here. I suppose I could set that to 49 and just make it an even number. Just go up a tiny bit. Maybe you saw that move. Because if we didn't do that, then there would be times that the camera would be looking at the back of the character and the crosshair would just unfortunately look like it was projected onto the character's back. And this is kind of a common thing in a lot of games where you have like this over-the-shoulder type of point of view. But I still missed, right? Okay, so we're going to fix that now. Let's go back into the event graph for our character. And now we're going to implement our aiming. Okay, so here's where I'm calling that custom event. Okay, cast power, remember, it starts off all this stuff for the playing sounds and the montage and the spawning of the projectile. I'll disconnect that for the time being and get it out of the way. Okay, so what I want to do first off of my input, pressed, pull off of that and type line trace by channel. Okay, now there's lots of different types of traces, but don't type trace first because you're going to see a whole bunch of other ones, but you just want this normal one, line trace by channel, not multi-line trace by channel. This is the one you want. Okay, and what this wants is a starting point and an ending point. So the way you can think of a line trace is think of it as an invisible sort of beam, a beam of invisible light, I suppose. You could think of it that way. We can actually make it visible for troubleshooting and for debugging purposes. I'll show you how to do that too in a moment. But I need it to, the line trace needs to know where does it begin and where does it end. Well, where it begins, I want it to begin basically with where I'm looking. Okay, where I'm looking from, the origin of where your viewpoint is. And it's counterintuitive, but your viewpoint into the world when you're playing the game is not the character's face or the character's eyes or anything like that in a third-person game. The origin of your eyesight, your point of view is actually the camera's location. So what we're going to do is we're going to get the follow camera component and bring that into the graph first. Okay, so there it is. And we need some information from this follow camera. First of all, we're going to need its world location. So we're going to type get world location, like that. Except for the fact that we've got to spell it, right? Okay, get world location, and simply that can go into the start of our line trace by channel. The end is a little more tricky. Okay, so what we're going to do is we're going to pull off the follow camera again and get world rotation instead. Okay, and we need to get the x-axis, the forward vector of the rotation of our follow camera. Okay, so we're going to pull off of here and type get forward vector. Okay. Now we're going to multiply this by a certain amount, and on the x-axis we want to multiply that by how many units long we want the trace to be from the starting position, which is at the location of the camera. So I usually create a variable for that. So let's make a new variable of type float. Usually you know that this defaults to Boolean, right? And then it says please compile the blueprint, but you know you can compile it if you want. But I'm going to change this anyway to float. And I still can't set the default. Actually, I'm going to rename this also before I recompile. Rename, I'll call it trace distance. And it's going to be a float variable. But again, I can't set the value until I compile. So let's do that. And we're going to set this to a big number, like 10,000. Okay? And that'll allow me to shoot a pretty good distance. So we're going to get our trace distance and pull that into the graph as well. Okay? Oops. And we're going to use the get, not the set. Okay? And what I want to do now is pull off of here and type multiply and just a regular operator. Okay? I did that too fast, so let me show you again. So pull off and type multiply and make sure it's the one that's under operators like that. And because I have this node down here, the trace distance, I'm just going to hold down Control and take the A and put it into the B, and then use this to feed the A so that the wires don't cross. And it doesn't matter which is A and which is B because of, well, because of what we learned in school, right? The commutative property of multiplication. Doesn't matter which is A and which is B. And now I've got to add this to this value. So I'm going to pull off of here and type add. And again, you want just the regular operator. Pull off of there, plug that in, and this is going to be the end of the line trace. Okay? For the trace channel, I want to use the camera. And in order to tell whether or not it's working, I need to set the draw debug type to for duration. And that's going to allow us to see the line traces while we're testing this out. Okay? And for the time being, they are not going to align with the crosshair, but we're still going to see what direction the camera is facing you know, once we start pressing the left mouse button to fire off our magic spell. And it's not going to align. You'll see that shortly. Actually, what's happening there? Did I leave something in here that I didn't intend? No. Okay. But I'll make an even better point here. Okay, we will go ahead and cast our power, and we're not going to be shooting at the crosshair. I really want you to see that this is still going to be wrong. Right? It looks like, I mean, the line trace is hitting where it's supposed to hit. But the projectile is not aiming at that location. Okay, so we need to fix that specifically. So at least this gets the line trace firing at the center of the screen towards the crosshair. Now line traces, and by the way, that line was the debug, draw debug type for duration. I'll leave that on for the time being. Line traces are collision based, and they will produce an out hit and hit events, right? So if I pull off here, I can type break hit result and then twirl down this disclosure triangle and get lots of information about where it hit and what it hit. You don't necessarily need this node because it's all wrapped up in this struct right here, out hit. So if I right click that and split it, I get all of the same information. Okay? So one thing that's really cool is what I can do is I can get the out hit location and I can promote that to a variable Or, even better, I can get the out hit impact point, which is even more precise, and promote that to a variable. So let's do that. Promote that to a variable and set it. Okay? Out hit impact point. Now keep in mind that the spawning of the projectile is not going to happen until way after. As a matter of fact, let me just make this chronological. This could probably make it easier to understand. Okay, let's say I'm calling the custom event there. Okay, it's not going to be accurate. I'm going to show you this again, but this just shows you in chronological order that before we even call the custom event, the line trace is instantaneous. So many ticks in advance of spawning the projectile, it's going to populate this variable called outHitImpactPoint. So still not going to be right. But the line trace is right. Okay, and we now have this variable called outHitImpactPoint. And now this is where the magic happens, because if I come back here and all of this weird math that we had to do to get the rotation right, we can now delete. Okay, we don't need that at all. Okay, we still need the spawn transform location, which is our scene component, but what's the rotation going to be? So you can't just use the impact point directly and convert it to a rotator. You've got to use find look at rotation and get the world rotation of the scene component. That is the start. And then the target is going to be our populated variable outHitImpactPoint, which outputs a rotator, does not have to be converted into the spawn transform rotation. Now, I did not play test this yet while I had it paused because it just occurred to me like immediately after I paused the recording. So let's see if that's it. And if it's not, I'm going to be very embarrassed, but I'm pretty sure that's all it was. Spot on. It's going to hit exactly where the line trace makes contact. I want to shoot the robot. No problem from any distance because I've got this crosshair. And anything else? Yeah, I just enabled physics on some of the miscellaneous objects that I just placed around this level, and I set their masses just randomly. And that, of course, is determining their responses to being hit. As far as the robot is concerned, I didn't do much. All I did is I implemented a montage based on the capsule component on component hit. Okay, so I right-clicked on that, and I got the event on component hit. And we played a certain sound, a mechanical robot noise, and another robot vocalization, again, that I got from the marketplace. I didn't even create it myself. Because, of course, this is just about, aiming. But, having the sound in there is helpful. I did make that music a little earlier today, but that's nothing special unto itself. So I've got it playing the montage, and just like the way that we usually do, accompanied with some sound. And as far as the capsule is concerned, I just set that to block all. Okay, so if we go down to where the collision is, I set it to block all. I turned off character can step up on, and I said simulation generates hit events. So all of those things have to be true, right? And if you are not getting a result, I would twirl that down and then make sure that this says collision enabled query and physics. If it doesn't, you can set this from block all to custom. If it's set to something else, just set it to this one, collision-enabled query and physics. Okay, right there. Okay, and that's all you need to do for that. And on the projectile, of course, there has to be a collision, but we talked about how to make projectiles where the default scene root is in fact the projectile collision volume itself. We've made that video already, so I don't need to review that. But anyway, now that I've got a crosshair, I can have some fun with this and maybe make this character not just stand there, but also come after me, try to attack me as well. We'll do that in a future video. And maybe give it a health variable so we can kill it, etc. But for now, let's just go shoot some magic powers around. Oh yeah, I forgot to turn off the debug trace. So let's go back to our line trace by channel node. And draw debug type, we'll say none, and we won't have to look at those line traces anymore. One last time. Wow, it ricocheted. So cool. That's a heck of a lot of fun. All right. Well, in any case, I hope this video helped, and I will see you next time. Have fun. Bye-bye.